Hello my precious friends, I really hope that you are doing great. Welcome to our today's class. It's our fourth lesson on a given Form 3 mathematics topic called Approximations and Errors. So we are looking at our fourth example, which is a past KCSE question tested in 202, paper 2, question number 8. It reads that the side of a triangle were measured and recorded as 8 cm, 10 cm, and 15 centimeters. Calculate the percentage error in the perimeter correct to 2 decimal places. So we'll start by getting the absolute error. The absolute error in the sides of this particular triangle. The absolute error in the sides of the triangle. The sides of the triangle, which will be given by, since all the given dimensions, that is 8 cm, 10 cm, and 15 centimeters, are all whole numbers, it means that the absolute error in the sides of this particular triangle will be given by a half of 1. Remember, when the dimensions are whole numbers, the absolute error will be given by a half of 1, which will give us, of course, 0.5. Therefore, we can get the limits within which these particular sides exist. So I'll start with the first side, which is 8 cm. So I'll have 8 cm. So I'll get the upper limit of this particular 8 cm. To get the upper limit, you will simply take 8, then you add the absolute error. So 8 plus 0.5, I'll get 8.5 as the upper limit of this particular side of 8 cm. Now, to get the lower limit, you take 8 minus 0.5, of course, which will give us 7.5. We also get the limit within which 10 exists. So we'll have 10. The upper limit will be 10 plus 0.5, which will give us 10.5. Then, of course, the lower limit will be 10 minus 0.5, which will give us 9.5. Then the other side is 15 centimeters. The upper limit will be 15 plus 0.5, which will give us 15.5. Then, of course, the lower limit will be 15 minus 0.5, which will give us 14.5. Now, because the question wants us to find the percentage error in the perimeter, so of course, we'll start by getting the absolute error in the perimeter, which is always given by a half of the maximum perimeter minus the minimum perimeter under the brackets. So let's start by finding the maximum possible perimeter of this particular triangle, which I'm going to denote as P max. So the maximum possible perimeter will be given by, remember, perimeter of a triangle is given by a side plus side plus side. Therefore, if we want to get the maximum possible perimeter, we'll take the maximum side, then we also add the second maximum side, then we also add the third maximum side. So this will give us, so the first maximum side, of course, I'll pick 8.5, which is the maximum of the side, which was 8 cm. Then the maximum of the second side is 10.5, so plus 10.5. Then the third maximum side, of course, will be 15.5. So I'm adding because the perimeter is usually the summation of the sides. So you feed this on your calculator, 8.5 plus 10.5 plus 15.5. This one is going to give us a total of 34.5 centimeters. Therefore, this is the maximum possible perimeter for this particular triangle. We'll also get the minimum possible perimeter, because when we'll be getting the absolute error in the perimeter, we'll need both the maximum and the minimum values. So P minimum, the minimum possible perimeter, will be given by the summation of the minimum possible side plus the summation of the other minimum side plus the summation of the third minimum side, which will be given by, so the minimum possible sides for 8, we have 7.5. Then, of course, plus 7.5 plus. The minimum for 10, of course, is 9.5. Then plus the minimum for 15, of course, will be 14.5. Therefore, when you feed this on your calculator, that is 7.5 plus 9.5 plus 14.5, you'll get a total of 31.5. Therefore, we can now get what we call the absolute error in the perimeter of this particular triangle. So absolute, the absolute error in the perimeter of the triangle, absolute error in the perimeter of our triangle will be given by the following formula. This one is always given by a half of the maximum perimeter, so P max, then of course minus the minimum perimeter, P minimum, which will give us a half into bracket the maximum possible perimeter. We had gotten it as 34.5, so this is 34.5, then of course minus the minimum possible perimeter was 31.5, so minus 31.5, close the bracket. So this will give us a half of, if you take 34.5 minus 31.5, you'll get 3. So of course, a half of 3, this will give us 1.5 centimeter, of course, as the absolute error in the perimeter of this particular triangle. Now, remember the question wanted us to get the percentage error in the perimeter of the triangle. So of course, to get the percentage error, we'll need to have the absolute error in the perimeter and also the actual perimeter. Therefore, I will get the actual perimeter of this particular triangle. So I'll say the actual perimeter of the triangle, actual perimeter of the triangle will be given by the following formula. So actual perimeter will just use the actual dimensions. So this will be side plus side plus side, which will be given by, the first side was 8 centimeter, the second side was 10 centimeter, then of course the third side was 15 centimeters. Now, if you perform this summation, that is 8 plus 10 plus 15, you'll get a total of 33 centimeters as the actual perimeter of the triangle. Therefore, to get the percentage error, so the percentage error in the perimeter of the triangle, percentage error in the perimeter of our triangle will be given by the following. So percentage error is always given by absolute error, the absolute error in the perimeter, absolute error in the perimeter of our triangle, absolute error in the perimeter of the triangle, divided by, so we'll have absolute error in the perimeter of the triangle divided by the actual perimeter of the triangle, actual perimeter of our triangle, actual perimeter, then of course multiplied by 100%. So remember, absolute error of the perimeter divided by the actual perimeter, that one represents what we call the relative error in the perimeter. So this will be given by the actual, that is the absolute error in the perimeter. We got the answer as 1.5. So this will be 1.5, then of course divided by the actual perimeter. We got it as 33 centimeters, then of course multiplied by 100%. Now, if we compute this on our calculator, this is what we are going to get. So the percentage error in the perimeter of the triangle, percentage error in the perimeter of our triangle will be given by the following. So you compute this on your calculator, that is 1.5 over 33 multiplied by 100%. This will give us a 4 whole number, 6 over 11, 6 over 11%. Remember, we said questions involving errors, it is advised to leave your answer as a mixed fraction, because fractions usually represent accurate answers or answers which are not approximated or exact answers. But if the instructions of the question to leave your answer to a certain decimal point or significant figures, then of course the instructions have to be considered. For example, in this case, we are told to leave our answer correct to 2 decimal places. Therefore, you convert this to decimal place to 2 decimal places. This will give you 4.55%. Therefore, this is the percentage error correct to 2 decimal places. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you will get notified. Until next time, this is Kind Tuition Academy. Thank you very much.